I would like to invite Professor A.B. Raju. His talk is on using Scilab or XCOS in teaching and learning, and he's sharing his experiences.
Good evening, everybody. I am Professor Raju, working at BUB Engineering College, Hubli, in north part of Karnataka. I have my outline, presentation outline is like this: introduction. Thank you, sir. Thank you. Introduction, and where actually I get the computational requirement, and then why did we choose Scilab for this catering for this computing requirement. And right now in my department, in electrical and electronics engineering department, where is that I'm using Scilab, and some sharing, I will be sharing the experiences out of these implementation, and have student reflections, challenges that we are facing, as well as opportunities for the improvement. Yeah, this BUB College of Engineering and Technology is located at Hubli in north part of Karnataka. It is an academic autonomous institute under Visvesvaraya Technological University, Belgavi. We design our own curriculum and deliver and conduct examination. Every year we revise our curriculum. Otherwise, in university system, every 3 or 4 years they revise curriculum. And then we recommend the successful students to the university, and the university will be granting the degrees to them. And so because we are academic autonomous, we have an opportunity, we can cash in on this opportunity for introducing best practices in teaching and learning. We follow outcome-based education system. That is, we design our curriculum based on OBE framework. In OBE, what is that we do is, each program has got its own program educational objectives. And based on these PEOs, we frame our program outcomes. And based on these program outcomes, we write course level outcomes as well as the topic level outcomes. So this is what is being expected from NBE, National Board of Accreditation in India. And where does the computing requirement arises? Actually, engineering students are expected to design and develop components, systems and processes. And when they are designing this, they should be aware of constraints, follow ethical procedures and standards. And before anybody, before full-scale production of any design system, they check the viability and they do prototype. They might do destructive test, non-destructive test, etc. Or nowadays, computers with good power is available with a lower cost, affordable. And so I can use computer for checking the viability, or I can predict how actually my system or the component or the process is going to behave or perform. So let's see the requirements insisted by Accreditation Board for Engineering and Technology, ABET. So the first one, actually the alphabets in this brackets are the A to K outcomes. And for the computing requirements, yes, these are the outcomes that are necessary. The first one is our students, graduate students should be able to know and apply knowledge of mathematics, science and engineering, an ability to design and conduct experiments as well as to analyze and interpret data, an ability to design a system, component or processes to meet desired needs, an ability to identify, formulate and solve engineering problems, and the last one, an ability to use techniques, skills and modern engineering tools necessary for engineering practice. After all, scientific computing is nothing but to gain understanding, mainly through the analysis of mathematical models. You load the data, do some, change the analysis procedure, change some parameters, see the visualization, and again modify. So this is where the computing requirement is arising. And why did we choose, Scilab? It's a higher level language, easy to learn, and has interactive data visualization component inbuilt into this. One can concentrate on problem solving instead of you concentrating on syntax, braces, semicolons, etc., etc. Yes, you will directly concentrate on problem solving. And it's free and open source software, so everybody, the student, will use this software not only in the college campus, even outside or wherever he goes, even to his working place also. So community participation, so there is a constant growth because of the community. And good ecosystem, supposing that if I want to say have routines for the statistics, yes, it's there, statistics package or toolbox is there in Scilab. And this is the XCOS is present only in Scilab when compared to other computing environments, like it's not there in Python, it's not there in Julia, it's not there in Octave, it's not there in say the other one I missed. Okay, so this feature is significant to engineering students because we are always, whenever we explain something, we generally write a block diagram and what is the input and what's the output, you know, those things we mention. So this XCOS is important for us. And where is that we are using Scilab in Department of Electrical Engineering? So we use Scilab during the course delivery, whenever we are, you know, teaching something. Say for example, rotating magnetic field in an induction machine. So I write a code, execute it, and show in the classroom. So there, and we use it in power system lab. Right now we are using DSP lab, electrical machines lab. I will tell you how the requirement are arising in electrical machines lab, control system lab, and our students will be doing mini and minor projects. One in 5th semester, one in 6th semester, and the capstone project is in 7th and the 8th semester. And the last one is the research experiences for undergraduate projects. In the department, we choose meritorious students, and we want to impart them research, some sort of research experiences for them. Actually, these students will be working with persons who are having a PhD degree. So some kind of research experience will be given to these UG students. So I myself have used this Scilab XCOS for self-study component in a coursework known as power electronics. And the problem that I gave was design a DC-DC power converter for given specifications. For example, output voltage must be something for this input voltage. Say current ripple should be something, voltage ripple should be something. So these specifications are given, and then verify or check the viability, the solution through using Scilab XCOS simulation. So this is one of them I'm showing you. This is a Cook type DC-DC converter. Basically, what is that we are doing is, we write state space equations for this converter to work. When the switch is on and when the switch is off, I write state space equations, and these equations I will use for simulation. And if you simulate it using XCOS, it will be something like this. Actually, if you look at this, there are 1, 2, 3, 4 state variables, 2 inductors and 2 capacitances. So you will have 4 differential equations. You are getting to see 4 differential equations, and so then you have 4 components here, big components here, so as to simulate this power converter. And I will show the output here. The first graph is representing the currents through these 2 inductors. The other one is representing the voltages across the capacitors. Well, I have given the specification, and these are simulation results I have got for particular values of component values. And this is one example of a control system, open loop speed control of a DC motor, wherein they just they would study that as the load is increased on the DC motor, the speed of the DC motor is going to come down. Now, how do I do it in the closed loop? Yes, I use XCOS for doing this. Actually here in the input side, I am giving a step input, setting the speed command, and then you can see here that there is a PID controller. So the students will be changing the parameters and would see what's happening, etc. So it's an exploratory kind of thing. And these are the graphs. For the first one, the set speed was 100, and the next suddenly it is the set speed is changed to 200 radians per second, and basically this DC motor is driving a pump type load. So as the speed is increasing, so the torque is also going to increase, so that you can visualize using noting the currents, armature currents. And yeah, I use this for the application of design of experiment principles in electrical machines laboratory. Basically, I have a physical system or a process. It has got an input and the output. It has got control factors. So I do the experimentation changing these control factors in a particular fashion. It might be a full factorial design. So I do experiments according to the DOE concepts. I gather the data, and then I do statistical analysis and come up with a mathematical model. So the mathematical model will be like y equal to b naught plus b1x. It can be a quadratic or it can be a cubic also. So that one is done on a DC motor. Although in electrical engineering we know what are the DC machine equations. Yes, I can predict it, but this perspective is something different in the sense we are looking at the DC motor as a black box, the control factors, and it's maybe I will say it's a this model is for statistic purpose in the sense empirical model type. So now my control factors are external resistance, armature resistance, and field current and the armature current. So basically we have done about 27 experiments, each control factor at 3 different levels. And yes, here this is the predicted speed and the obtained speed through experiment. That's the error. That was the top one is showing the error graph. And this is the equation that I have got. This is the empirical model. And here, yes, I have used statistics toolbox of Scilab. And this is the student's reflection. These are the one. It is an open source and free software. It's an advantage. They can share this, the software with everybody. Can use not only in the college campus, outside also, and easy to learn. Unlike C, C++, etc., it's easy to learn. Emphasize more on problem solving. Yeah, you don't have to worry about the syntax, etc., etc. And strengthens theoretical concepts during problem solving because you will be working mostly with mathematics or equations. So strengthen your concepts. And model implementation is based on signal flow graph or block diagram approach. So that's where we see the advantage. And the challenges. The first challenge is many students doesn't know about this. We need to popularize this Scilab. The second one is really, today morning I saw that some person from Nissan, he said for automotive industry they are using Scilab. But the people who are coming for the placement interview at our place, they insist that students should be knowing something about MATLAB. So that's where our students fail. And very few students interviews are aware of Scilab. Even the interviewers themselves don't know about Scilab. So how they ask questions on Scilab. And the students are not aware of easy migration because if I learn Scilab, well, it doesn't take much time to migrate to say Python, to migrate to even a proprietary software. So it doesn't take much time. And I think, early introduction is required for all, maybe in primary, high school or the college. That's what I say. Yeah, then the opportunities, what I see the opportunities here. Introduce Scilab for all the students whenever they start learning mathematics. You should not delay it. Like scope for improvement in appearance and usage like the GUI editor, debugging facility, and resources available. Exploring applications of Scilab in embedded systems. Why only Arduino? I should be using Scilab. Scilab should be supporting EXBIs as well as microhope, which were developed by Ajit Kumar. SciPy is going to come up. So, and we should be able to market low-cost embedded boards like EXBIs or microhope, and want Scilab on a Google Play Store. Then standard textbooks with Scilab program. So far I have come across only one textbook on digital control system by Professor Kannan Madhugilla, where he has used Scilab in this textbook. So I would like to see those kind of textbooks more. You see often more textbooks on using MATLAB or using PSpice, etc., etc., but would like to see more books like using Python. And thank you. Any questions?
Sir, in MATLAB, there is a toolbox called SimPar system. So, is there a similar toolbox in Scilab for a power system or power electronic simulation?
Actually, in Modelica, they are coming up with these things. Some switches, yeah, are there, but yeah, there is a scope for improvement. Like in MATLAB and SimPower systems, you also have models for machines.
Yes.
Yeah, induction machine, alternators, etc., etc. But yes, they can be added in Scilab also.
And in MATLAB, we have a MATLAB function block in which we can write the code directly. So is it there in Scilab as well? Because the equation which you showed, which you solved using state space equations,
Yeah.
that can we put the code directly if we have that?
No. Wait a minute. I will show you actually what is that I have done. Yeah, in this expression, on a top right corner expression, I have written the equation. I have not written any other thing.
Okay.
It's possible. Even I think Scilab code can be interfaced to this XCOS input and output.
Okay.
Yes.
And I have one more question, that is Scilab a circuit solver or is it an equation solver?
Basically, it solves the mathematical equations.
Okay.
Basically, it's a mathematical software. So it cannot emulate a circuit simulation software.
Yes.
Yes.
Okay. Thank you.